And here we go. Problem of the day today. If one angle of a parallelogram has a measure of 40 degrees, find the measure of its other three angles. All right, so one angle of a parallelogram we know has a measure of 40 degrees. We're going to find the measures of the other three angles because it's a quadrilateral, right? So let's see how we're going to do this one. All right, we're going to see how we're going to do this thing. We have a quadrilateral with a parallelogram shaped look here. There we go. And all in yellow here, a little green writing stuff there. But again, we have a key word here. Well, one of the key words. We always like those numbers, don't we? But it's a parallelogram. And what happens with a parallelogram? All sorts of great things happen, all right? It's a specialized quadrilateral. It is four sides. And first of all, true to its name, it has parallel sides. Not one pair, but two pairs. Now, once the parallel sides run into motion, if I were to slide a little triangle diagonal going through here, in other words, one nice thing would develop two triangles. Those triangles will be congruent, and all of a sudden we start being able to notice some things about, wow, these angles here, all right? Now, in these angles, we got two different things going on here, all right? First of all, you know what I'm going to do? We're going to get 40 right up here in this corner. Now you say, Ernie, does it matter? Well, I know 40 is acute, and these two certainly are not acute, and you're probably saying, oh, I bet those are both congruent. Yes, they are, because they're what we call opposite angles of a parallelogram. So I just gave away what's going to happen down here. We're going to have a 40 degrees also. So there you go. There are a lot of ways to figure out the final two. The main thing is noticing you've got parallels going here, and these are what we call consecutive angles. Let me put a letter on there for you. How about there's A, B. While we're at it, we'll go ahead and put C and D down through here. But A and B, the angle A and the angle B obviously are not the same size, all right? Now, if they were right angles, we'd be good. We'd have a rectangle, be a parallelogram probably in this situation. We have the parallels and we have right angles, but we don't have that. We've got a 40-degree angle down here. And what we need is to find what is going to make, what degree measure keeps these lines parallel, or what degree angle comes from having the parallel lines. We've already got parallel lines established. It's a parallelogram. That's not what we're trying to show. So here we go. We've got 40 degrees. We've already marked it right there, matching up with that. So these two angles, because they are same side interior, if you look at this transversal. Oh yeah, AB is a transversal with parallel lines. And we know angles inside the parallel line game are either going to be what? Congruent or supplementary. And this is the supplementary version right here. So this guy is going to be 140 because those two numbers have to add up to 180, all right? Now you say, what about angle C? Well, you can play the same game we did here with the 40 and 40. You know it's going to be, they're opposite angles, so they're going to be congruent, going to have the same measure. So we put 140. But what about our parallel line business? Are they consecutive interior? Well, C and D are. They're a pair of consecutive interiors, so yes, they're going to add up to 180. How about it? B and C. Oh my goodness, there's those parallels. See where my hands are trying to slide? Yeah. And there in BC becomes the transversal there. All right. So those two have to add up to 180. While we're at it, how about it? More same side interior here. 140 and 40. A lot of times we call those consecutive interior when we're in the parallelogram. Consecutive interior angles of your parallelogram. There they are, and they are supplementary. Sometimes we just call them consecutive angles, all right, because they are inside, obviously. So consecutive angles of a parallelogram, opposite angles of a parallelogram, everything's either congruent or supplementary. That's the beauty of it. It's the beauty of it. So once again, opposite angles, 140 each. 40 here. So what are the measure of the other three angles? We started with 40, so we had two that are 140 and one other at 40. By the way, if you want to do one more quick check, they do add up to 360 degrees as you go around the figure there. So there you have it. Kind of a little nutshell about the angles of just a typical old parallelogram. If you know one, you've got all four.